Okay, just a quick review of the new concept for today. It's intervals of increase and intervals of decrease. And increasing intervals are when your y values are going up, and then decreasing are when your y values are going down. And we talked about this in class today, but the intervals that you write are actually going to be the x intervals. So I want to show you on this particular graph. You can see that from the x here, from A to B, it is increasing. So without having to find the x values, which I will do for you in just a second, let me just kind of show you the concept at a high level. So it increases from A to B, and then it decreases from B to C. Then it increases from C all the way up to D. So I told you use a union symbol. So I'm basically joining two intervals that are actually not side by side. And then, so that will be C to D. And then D to E is another decreasing interval. So that's the overall concept. But remember that you're basically breaking apart your x-axis. So I will do the increasing intervals in red just to kind of show you. And then I'll do the decreasing intervals in blue. So anywhere on here that you see red is where your y's are getting larger. So it's these x values between A and B, my y's are increasing. Again, from C to D, my y's are increasing. So that's the overall concept. So let's go to the graphing calculator. I told you I would do the first homework problem with you. So this is just the first function, negative 5x to the fourth minus 11x cubed. And you actually have it on your sheet of paper. So let me make sure, let me open that up for you real quick. So it's actually on the graph, but the reason I have to do it in the graphing calculator is because I specifically need to find this point, and this point. So this is going to be an absolute maximum value. So that's going to be the highest y attainable. This will be a relative or local minimum. So it's not the absolute lowest point on the graph, but it is relative to those around it is the lowest. And then this again is a relative or a local maximum. So I want to find those points on my graph. So the first thing I'm going to do is locate this maximum here. So second, calculate. We did this in class today. I'm going to do option 4. And I want to just travel the graph until I'm to the left of that maximum. Just somewhere to the left of it. I'm not being like strategic in the location here. I'm just picking a location. It's saying enter left, go to the right, and there's a little hint down here that you need to go to the right. Anywhere along here will be fine. Enter and enter. That last enter was for guessing. So I have a maximum at negative 1.59, 4.25. So I want to go in and write that down. So write in negative 1.59, and then it goes 4.25 is the y value. Okay, now let's go and find this relative minimum. So go back to the calculator. So second, calculate, and now I want to find a minimum, 3. So I'm going to go to the left of that minimum. Anywhere along here is fine. Press enter, go to the right, just somewhere along here, press enter, and now it says guess. So I want to press enter again. So if you get stuck, just kind of look down at the bottom and it tells you what you need to do next. So negative 0.46 and negative 2.70. So going back, let's write that information in. So this is negative 0.46, comma, negative 2.7. Okay, making sure y'all can read that. And going back to find this relative max, or it's a local max, it's the same thing. Relative and local mean the same thing. In that local area, no, I didn't want a minimum, did I? So I'm going to go back and do second calc. I want a maximum. So that's option 4. So somewhere in this area Okay, relative to all the other points, this is the highest point, or in this local region, this is the highest point. That makes it a local max. So do to the left, so I'm going to kind of just come up a little bit. Anywhere along here is fine for the left bound. Press enter, travel over, and press enter and enter to guess. So then I have 0.41 and 0.73. So that would be the next point. So 0.41 and 0.73. Okay, so let's go ahead and write in all of our information here. So the domain is going to be all real values. And the range will be all y's, because remember these are our x's. Let me just kind of review that. And then these are our y values. So when I have an absolute maximum, I know that's the highest y attainable, or the highest y I can have. So that'll be negative infinity up to 4.25 inclusive. Remember, that's what the bracket means. Local max, I only have one local max is right here, so 0.41, 0.73. Local min, I have one at negative 0.46, comma, negative 2.7. Absolute max is up here, the absolute highest point, negative 1.59. And then there's the highest y possible. And these are all points, so they're written with your x-y coordinate pair. And then the absolute min, there is not one, because it goes down to negative infinity. So there is no there's no absolute min. There's only this local min. Increasing interval. So guys, do you see that if I drop down, and we kind of talked about this in class some, if I sort of drop down right to this, I'm breaking my axis into little segments. My x-axis has to be broken into little segments. So basically, I have increasing y's all the way to this x. Then it decreases here to here. Then it increases again, and then it decreases again. And don't forget that you really have negative infinity to positive infinity here. Okay, so I'm increasing from negative infinity to this x of negative 1.59. So negative infinity to negative 1.59. And then I have decreasing intervals, the next little interval's decreasing. So I use this x, negative 1.59, and go to this x, negative 0.46. So negative 1.59, comma, negative 0.46. So it decreased from here to here. Then it increases over this little interval here. So negative 0.46, comma, and it's going to go to this x right here of 0.41. So there's my increasing, and then it decreases again from 0.41 to positive infinity. And that pretty much takes you through the lesson for today. Now I want to show you one other thing, is if I draw a number line, I just want to show you, I want to do a solid number line. Okay, so if I draw in a number line, and essentially if I take all of these x's and sort of drop them down to this number line, negative 1.59, take this x here, negative 0.46, take the next x of 0.41, and then I only had those three, so let me kind of highlight what I was doing. It's this x here, and then I go to the next local min or max, whatever you're finding next, and then that's going to be this x here, and then this x here. And I put them in order, and that's really important. And then remember that this is negative infinity to positive infinity. And I can kind of give assignments here. So I can say, over this interval, my y's are going up or increasing. Then it decreases. Then it increases. And then it decreases. So then I can just easily write in my notation. So negative infinity to negative 1.59 is this first one right here. And then it decreases, increases, and decreases. And this will help you write your interval notation. So when I write this out, I know automatically that from this X to this X, I have decreasing behavior, and I go up here and write it in this section. A lot of students don't want to take the time to do the number line, but if you are struggling with this, it's a fail-proof way to actually make sure you know how to do it. So that is today's lesson, and you need to finish graphs A, B, and C down below and do the same thing for those three. Y'all have a great day.